Okay, so let's start with the lecture second. So that is the magnetic field patterns. We are going to make it due to a long carrying wire. So you can imagine that you have a long carrying wire. Around that, how the magnetic field will be generated. So that we are going to be look into that and what the pattern of that one is. So let's suppose that we have a wire. So in that wire, the current is going like this, the upward. So there will be a concentric circle get formed over there. So let me try to make it first. And so these are the concentric circles that I made it. And so this is the pattern of that. To determine the direction for that, the magnetic field, what you can think it, you can take your pen, you can hold your pen. So in your hand and hold it like this. So just think it like this, the current is going up in this one. So of the right hand, your thumb is pointing it upward and curl your fingers like this. So this is your fingers, the direction of the fingers, how they are curling. This is the direction of the magnetic field around a current carrying wire. The current is going up. So magnetic field lines like this. These are concentric circles that get formed. If the current is going down, so you have to tilt like this down, and your thumb is pointing it down, and then you had to be thumb is down, and you have to curl the fingers like this. So it is concentric circles that get formed over there. And now, if the current is going like this, and then the thumb is in this direction, and then the current is going like this, the pin of the so, and then you have to curl like this. So this is 3D. You have to imagine in a 3D. So this is the direction of the magnetic field because it is going up and you have to curl your fingers like this. So these are the concentric circle directions. This is, we call it a right hand grip rule. This experiment is done by the first time is the Oster. So that's why we call it a Oster experiment. He done some kind of the observation that when you own the current in the wire, so it had the magnetic field around that. To check it out, so he owned the current. As you own the current in the wire, there is a deflection in the magnetic needle. So that is the give the proof for there should be some kind of the magnetic field around that. And he done the bunch of the other things also with that. And as you change the battery direction, so the magnetic field direction also changes. Before it is the north is pointing it downward, now it is upward. This is the one observation that the current direction gets changed, so the magnetic field direction also gets changed with that one. The another one is he done the observation that as you increase the current, magnetic field around that, it will also increase. Electrons always move in the opposite direction. The current direction is always, conventional current direction is always from the positive terminal of the battery to the negative terminal, and the electron always move in the opposite direction of that one. This is another nice demonstration that we have it the magnetic field around a wire. So you have a wire right now. There is no battery, so there is no current right now that is passing through. So you can see these iron fillings. These are the iron filling. They are disaligned. They are not aligned. So as you own that, as you connect the battery, you can see some of the magnetic field lines get arranged, and you can see that clearly the magnetic field is get um, around a wire. So this is the concentric circle, but right now they have made the one of them. And you can apply the right hand rule, basically right hand curl rule, you can say right hand rule, you can say thumb is the direction of the current and you have to curl your fingers. And as you can see the bunch of the things. As I'm increasing the current, you can see the magnetic field strength near to the wire is increasing. That you can see it here clearly how they are aligned more properly, this iron, because they get magnetized. The iron fillings get magnetized, so they get arranged very well. So you can see this one clearly. So as I remove this one, so it is the magnetic field. But as I switch the current direction, so now right now it is like this. So you have to curl your fingers like this. It is going like this. Now, as you go down, the direction of the magnetic field should change according to the right hand rule. So as you flip it like this, so the magnetic field direction has changed right now. So it gets changed. And as you are more close to the these lines, more stronger the magnetic field strength is. As you go further away from the wire, the magnetic field strength decreases. This is also the one of the, again, we have the magnetic field around a circular wire. We talked about that one. So you have a circular arc, you can see that one. So right now the formation of the current is going like this upward. You can do your thumb upward and you can curl your fingers. So if you curl your fingers, you can clearly see that your fingers are curling like this. So this is the magnetic field direction, and even you can see these magnetic compass. So that is pointing out like this. So this is magnetic field direction that I'm drawing it like this. So it is going into here, it is coming out of the screen. So this is 3D. You have to imagine the 3D. So this is the wire. So it is going into to this side, right side of me, and it is coming out from this side. And so here, if you look at this carefully, if I have to make it like this and like this, so it's hard to make it over there. But if you try to understand that one, this is the front side of that one. So the current is going like this. So a thumb is on this side and it is going like this. So on this side, it is going downward. So if it is going into that one, into the screen, and it is coming out of the upper side of that. And here you can see that one, if you apply that, current is going down, and this is the direction for that one. So basically this direction. So you have the concentric circles like that. Let me show you with the right hand rule on how it is going to be very. This is the right hand. So it is going into, and if I curl that one, so you can see that clearly how if you place it anywhere, look at that. If you place it anywhere, the magnetic field lines are going into that, into the loop, but they are always closed. So they are always closed loop. So it is going into that. There is another simple way to do that one is, the another simple way to do, if we had a circular arc, listen to me very carefully, it is might be confusing for you. So if we had a circular arc, the current is going through a circular arc right now. So the current is going like this. So if the current is taking the circular arc, so better to find out the direction of the magnetic field, what you can do is you can curl your fingers like that. I'm just saying opposite to that now. Now you have to your fingers are in the current direction, and the thumb will give the magnetic field. It is just opposite that I'm telling you before. Now, if this is only you have to apply when the loops are circular loops. So what you can do is you can apply this one. Let me remove this one. It is might be confusing for you. So you had to be move your fingers like that. You have to move your fingers like that now. And the thumb is telling the magnetic field. That's why before, if you seen it carefully, the magnetic field is going inward. So this thumb is giving the direction for that. So this is magnetic field lines are going into the screen. You have to imagine like this. It is going into the screen. Hopefully you understood that one. So this is the right hand corkscrew rule also that they have written in the textbook. Now, this is the back side. This is the back side of that one. This is the front side. This is the front side. From the front side, it is going down, and the current is going up. So you can think it like this. It is going like this, upward and downward. So the thumb is pointing like this. So this is the north pole because it will behave like a magnet right now. If you know that one, in the magnetic that we discussed in the first lecture. So magnetic field always come out from the north and goes to the south. It is the same thing is happening, but with the loop right now. So so if you look at this carefully, this loop is behaving like a some kind of the magnetic field. So the magnetic field lines are coming out from that and going into that. Even you can remember like this also. If it is you have the current is going in the some kind of the anti-clockwise direction. Anti, you can remember like this anti, we have in the anti-clockwise, AN. N means north direction. So from the front side, if you look at this is north. And the back side, it is south. Because the magnetic field lines are going to be come out from that. So this is north. If you take it the loop like this, clockwise, then it is a south. South. You can remember like this. It is a south. Till now, what we understood is if you have any kind of the circular loop, it will just a circular current carrying loop act like a just like act like a bar magnet. Just think it like this is solenoid. A solenoid is nothing but you have the plenty of the copper wire, insulated copper wire is in the form of some kind of the cylindrical form something. This is copper wire, insulated copper wire. They are not attached with each other directly. So this is copper insulated wires. This is we call it a in the shape of cylinder solenoid. And this as the current will pass through that because every loop has the same current direction. So this is also act like a small magnet. You can think like this is also act like a small magnet. Their magnetic field will add up because it is a vector quantity. It get added up. So inside, so if it is a solenoid, you can think like this: the magnetic field, the same rule. If the current is taking the some kind of the circular loop, you have to curl your fingers like this, and the thumb is like this. So this is act like a north here. This is act like a south pole. This is act like a solenoid. Is act like a bar magnet here. And if we have the number of the turns are more, if the number of the turns are the more stronger the magnetic field strength is. As you can see, the number of the density has increased right now. Direction is still the same. Let's try to understand again how the direction you can find it out in a solenoid. So this is a small solenoid. So the current direction is always from the positive terminal to the negative terminal. So this is the current direction that is passing through. This is the current direction. So as you can see, each of the loop has a current is going down. So you had to, your fingers, your fingers is going like this. So this is north. Your fingers are going downward. So you have to curl like this. So you can think like this. Even you can curl this way and this way. So this is north. This is south. So it will act like a small magnet. So the magnetic field lines will go like this something. It originates from the north, go to the south, something. So you can see this one. This is how it will act like. So this is the south pole of the compass because this is the north pole. So it will attract that one. So you can see on the other side. So this is how the magnetic field.